Kylie and Steven here with Conic sections, a mathematical tool you'll use in everyday life.
From ice cream cones you eat, to the streets you drive on, to the clocks you see everywhere in your house, Conic sections do it all.
That's right, and if you don't believe us, we'll show you.
Yes, we will.
Conic sections can be turned into many different things. Steven, do you mind showing us how you can turn them into different sections?
Yes, I will show you how to cut them into different sections. First, I will cut a circle.
See?
Circle. Boom. Get that stuff straight, alright? And then next off we have a parabola. And I also cut it into an ellipse at the same time, alright? This
Parabola?
is parabola.
Parabolas.
Plural. And ellipse. Singular.
Right there. Shazam.
Shazam. Magical stuff
Bet
happens.
you didn't know that. Steven! Steven, are you there?
Ah, Kylie, this isn't a phone, this is a banana!
No, Steven. It's a parabola phone. So as you can see, there are many different instances in which parabolas are present in our daily lives. Take this door handle, for instance. It's two perfect parabolas.
Yes, it is. And for today, we're going to show you a little something of how to find some magical stuff about a parabola. Let's say that the base is 8 inches long. 8 inches. And let's say that the vertex is 3 inches away from the base.
3
inches. And so with this information, we're going to find the focus, the directrix, and then finally, we're going to want to place a window here away from the door handle so that the door handle isn't covering the window. And we're going to place the window 1 inch away from the directrix.
So, we took the points from 0, 4 to 0, -4, because together that would be a total of 8. And then we have from 0 to 3, so that's 3, 0 for peak to base. So then the equation is x equals a times y minus k squared plus h, which would be 0 equals a times 4 minus 0 squared plus 3. And those numbers come from this point and this point. So then you simplify it to 0 equals 16a plus 3. You subtract the 3 and you get -3 equals 16a. Then after you divide both sides by 16, you get a equals -3 over 16.
And then we come to the focus formula, which is a point form, so it's parentheses h plus 1 divided by 4a comma k, and the h equals 3, the k is 0, and 3 plus 1/4, a -3/16, and then multiplying that from the reciprocal, we get -4 divided by 3, and then we got a common denominator for the 3, which is going to be 9 divided by 3, and that simplifies to 5 divided by 3, 0.
And you can plot that right there on the graph.
And for the next formula is the directrix, and that's going to be d equals, so for the directrix, it's going to be a line, so x equals h minus 1 divided by 4a. And so we plug in h, 3 minus 1/4 divided by -3/16. And so that simplifies to -4 divided by 3. And it's going to be 3 minus a negative, so that turns into a positive. And then we got a common denominator for the 3 again. So that's going to be 9 divided by 3 plus 4 divided by 3. And so it's going to be 13 divided by 3 for the directrix. And
you can graph that right here, and it's a line because it's x equals.
And then to solve the problem, to find where we should place the window, we're going to add another inch. And so to get a common denominator, that's going to be 3 divided by 3 plus our directrix line, which is going to be 13 divided by 3 to get us 16 divided by 3 inches, which is also approximately 5.33 inches from the base. Ellipses are quite different from anything you've seen so far. They might seem like circles, but their special elliptical formula is quite different.
Right now, we're standing in a rectangular backyard that measures 20 feet by 30 feet. We want to put an elliptical pool in with the maximum surface area. And then we want to fill the remaining corners of the backyard in with 7-inch deep concrete. How many cubic feet of concrete is needed?
So we have our backyard plotted on the graph over here, and we placed the vertex, the center of origin, at 0, 0. And so our special elliptical formula is right here, x squared divided by a squared plus y squared divided by b squared equals 1. And so to find the value of a, it is the center, which is the vertex, 0, 0, to the end of the horizontal side, 15. So a is 15. And then for b, since that's on the y-axis, we're going to go from the center of origin and get the absolute value to the bottom vertical line, -10. So the absolute value is going to be 10. And so with that, we are finished.
So first, we're going to find the area of the whole entire backyard plot, which, as we already know, area is base times height. So that would be 20 times 30, which would make the area of the backyard 600 feet squared. Now we're going to look at the area of what our elliptical pool is going to be. And the formula for that is pi times a times b. So that gives us pi times the 15 times the 10. And then after you crank that math out, it'll be approximately 471.239 feet squared. And then to find the area of all of these corners that are going to be filled with concrete, you're going to take the area of the backyard, which is 600, and subtract the area of the ellipse, which is 471.239, and that will give you 128.761 feet squared that will need to be filled with concrete.
And since we want to fill the concrete at a depth of 7 inches, we have to convert 7 inches into feet. So that's going to be 7 divided by 12, and we multiply that by 128.761 to give us 75.111 feet squared of concrete in the corners of our backyard.
So then we take the 600 feet from the area of the backyard and subtract the area of the ellipse, which is, again, 471.239 feet squared. And that'll give us an answer of 128.761 feet squared that will be concrete.
Since the concrete is going to be adding a depth, it's going to become cubed. And so that will give us an approximate answer of 75.111 feet cubed of concrete in the corners of our rectangular backyard.
Circles. They are everywhere, even the globe.
Stephen, that's clearly a sphere. But after this example, you'll be doing circle problems like clockwork.
Oh, well, speaking of clockwork, we have a clock right here, and it's a circle this time, and I know that for a fact.
On this clock, the hour hand is located at a point 3,5, with the vertex at the origin. At this point, it is exactly 1 o'clock, as you can see. Find the radius of the circle, and then find another point on the clock in the 4th quadrant when x equals 2. Then approximate what time it would be at that point. So, we've drawn a clock on a coordinate plane, and our first point, we know that the vertex is at the origin, 0, 0, and then our second point is at 3, 5, which is graphed right there. So, moving from that, our first step is to find the radius. The formula for that is r squared equals x minus h squared plus y minus k squared. And when you plug that in, r squared would equal 3 from that coordinate minus 0 from the vertex squared plus 5 from that coordinate minus 0 from the vertex squared. When you simplify that, that will be r squared equals 9 plus 25. Then r squared will equal 36. You square root both sides to get rid of the squared, and you get radius equals 6 units. Now, Steven's going to tell you on how to find the new set of coordinates when the x equals 2 and it's in quadrant 4.
Going back to the formula of a circle, we have x minus h squared plus y minus k squared equals r squared. And since h and k are both zeros, we simplify that to x squared plus y squared equals 36. And x equals 2, so 2 squared plus y squared equals 36. 4 plus y squared equals 36. We subtract 4, and we have y squared equals 32. And then we're going to square root that to get y equals plus or minus 32. And then 32 can be simplified, and y equals plus or minus 4 square root 2. And since we know it's in quadrant 4, that y has to be negative, so it's y equals negative 4 square root 2. And so the point is going to be 2 comma negative 4 square root 2. And then if we go to the clock, we realize that that should be approximately 5:30 because it lies somewhere in between the 6 and the 5.
As you can see, conic sections are very intriguing and needed for basic human life. You need it. I need it. Your mom needs it. Your sister needs it.
And I need it. These examples are only the beginning for what is to come. So do not waste your time with parent graphs because those are basically like your parents.
And who wants to be reminded of their parents? I know I don't.
And who would want to think about boring, straight, linear, lingering lines?
Even saying it makes me feel like I only have one direction to go.
So join us. Invest in our conic sections. There's always a future with parabolas, circles, and ellipses. You can begin your dreams with an easy investment of only $19.99. While you're investing, we're inventing.
With your investment, you'll receive special access to more conic section releases and inventions so that you can be the smartest person around your block. Join now for only $19.99. Conic sections. They'll point you in the right direction.
Number for purchasing 1-800-555-Conic Sections. This product is not suitable for kids under the age of 15. This advertisement is not responsible for anything done with Conic Sections. You must be 18 years or older or be an Alpha 2 or a higher math class to understand the concepts. The side effects of this product are none. The only thing gained will be the smartest person on the block. Thank you.